36, 37. These are hard. I mean, 37's one of these is similar to this where you got to be able to factor it. Okay, it takes a little bit to get through that one, but the answer should be negative 2/3 and 1/2. And again, I'll have this on Canvas, like under today's notes. You can print the whole thing off. I don't care. All right, 39 is completing the square. Completing the square, we do want the constant on the other side, and this is where we take this constant 8, we cut it in half, and then you square that number, and that's what goes here. Now, sometimes we'll write it as 8/2 squared. It doesn't matter how you write it, but it's going to end up equaling 16. So you put 16 here, 16 here. That factors into x plus 4 times x plus 4. Negative 15 plus 16 is 1. Take the square root of both sides. Now you got, that just gives you x plus 4 here. Don't forget that's plus or minus, and the square root of 1 is just 1. And then that becomes x plus 4 equals plus or minus 1. Subtract 4. Should end up with negative 3, negative 5. Negative 3, negative 5. And I said, I think this part here is the hardest part, this little section. Okay, I think this is the hardest section on the exam. 40, you end up with, when you are done, negative 5/2 and negative 1. Now, if you get all of these correct from last night, that's amazing. If you got most of them, that's good. If you got one right, yeah, we got some work on it.
If you put like -1 and -5/2, is that still correct?
Yep.
Okay.
Yep. Not concerned about the order. That's fine. And now 41, you end up with some decimals. This here, you end up with the square root of 61 on the inside. So if you got to that part, that's pretty good. This right here is our radical answer. This right here is our decimal. Okay, so you got the radical and then you got the decimal for that. So I think that's what we went through. It's what, 41?
Yeah.
All right, for that. All right, we'll probably hit a couple more of those tomorrow. Like I said, I think that's the toughest part of the whole test is this little section here. Okay, have your note card handy because go ahead and I would just write these down right now because they're going to be on the test. They're from chapter 11. Arithmetic sequence, geometric sequence, exponential growth. Look at your notes right there.
I saw it. This is not 4 times 3 times, which ends up being -6. And then you get from 59. Sorry,
Where's that? All right, you got to put that at -1 squared.
you get 1.
Plus
Yeah.
6. Yeah, and then it's -4 times 3 times 5. Okay, that's gonna always put that negative number. Okay. All right, so the arithmetic a sub n equals a sub 1 plus n minus 1 times d. So that's arithmetic. Geometric is a sub n equals a sub 1 times r to the, oops, let me rewrite that. A sub n, a sub 1 times r to the n minus 1. And then exponential growth is y equals a times 1 plus r to the t power for time. And exponential decay is 1 minus r. Okay, we've had that enough, so you should be able to get away with that. I don't think there is a decay one on there. But there's a growth. So if you need to not quite all the way down, they're up there. All right, what is the 32nd term of the arithmetic sequence? All right, so we're on the guided notes here. So I'm telling you it's arithmetic. So we got a sub n equals a sub 1 plus n minus 1 times d. A sub 1 is the first term. That's -8. I'm just going to list this on the side. N is whatever term we're looking for. So n is 32. What is my d value in this case? D is however much is going up or however much is going down. So D in this case is what? Positive 3. So D is positive 3. So now I can substitute in to figure out what the 32nd term is. So A sub 32 is the first term, which is -8, plus 32 minus 1 times 3. Use your calculator, see what you get. Okay, you look at the sequence. It's going up each time by how much? It's going down, it's negative. So it's going up. Sam, you got anything? You got a big answer?
Yeah, I got 85.
85. What'd you get?
Man, I'm so out of it today.
What? How do we not know how to put this in a calculator? -8 plus. Now, 32 minus 1. That's 31 times 3. Okay.
That. What about ratio?
What'd you put in wrong, Grant?
I might have not put -4.
Oh, okay. All right. That next one there,
All you have to do is
Zenith.
That's a good name for it.
Zenith.
3 out there.
Christian, leave me alone. Please stop believing. You're hurting.
Doesn't always work.
I think they're less.
Stop being such a Christian. Stop.
This game, you're not squaring anything. You're squaring something.
You're such a bull.
It's a negative, you gotta put in parentheses. Christian.
Stop really.
Work on this
My
one.
feelings. Men have feelings.
If you're squaring something.
Monkeys do too.
Stop calling me a monkey. Your problem.
Put it in parentheses. All right, let's take a look at the next one. Zenith has 450 in her savings account. She plans to deposit 22 per week. Assuming she does not withdraw any more money from her account, what will be her balance in 18 weeks?
Exponential growth.
Not exponential growth.
Decay.
Okay,
Okay.
it's not decay. This is an arithmetic sequence. It is going up $22 every time. That is just like this last one, which is going up 3. You could list them out. It would start at 450. Then it would be 472. 494. So we can use this a sub n equals a sub 1 plus n minus 1 times d. Here's my case. A sub 1 A sub 1's $450. That's what you start with, $450. D is the amount it changes. We're putting in $22 a week, so D is 22. And we want to know how much we're going to have after 18 weeks, so N is 18. So it's no different than an arithmetic sequence. Plug into this equation. Joe, don't. A sub 18 equals A sub 1, which is 450, plus 18 minus 1 times 22.
So buddy, this is. Wait, what did you get? I got 824.
Okay. Connor, 824? Okay. Equals 824 for that one. All right, so that turns out to be an arithmetic sequence. Now, the next one they tell you is geometric. They tell you ahead of time. So we got A sub N, A sub 1 times R to the N minus 1. And A sub N equals A sub 1 times R to the N minus 1. They tell us the first term is 6. They want to know the 12th term. So that means N is 12. Okay, R is -3. A sub 1 is 6. So it's going to be A sub 12 equals 6 times -3 to the 12 minus 1. Now here's one where if you don't put this in -3 in parentheses in your calculator, you have a good chance of missing it. So, Jay Lee, let me know what you get.
A big number.
Big number.
Small.
How big?
Actually, no, it's very
Very
small.
small.
It's very small.
Well, big negative number.
Yeah.
What do you got?
1062,882.
That's it?
Actually, no.
-1,062,882.
Is that right?
I wish I had that much.
No, it's left.
Maybe don't.
Not funny.
Yeah, you don't want negative.
Oh wait, never mind.
Wait, is that right?
Yeah.
How?
What did you get?
I didn't do it.
That's how.
I'm just so confused. I didn't do it.
Hey, rocket science. Okay.
Open your boxes. Like, that's so confusing. What do we do now?
All right. Hey, let's get through this here.
Listen,
All right, take a look at this next one here.
Wait, what's my calculator? I can find it. I use a calculator, please.
All right, you nah, I calculated it full time.
I lost it.
All right, so this next one here, estimates the population to be 275,000, predicts the population to grow at an annual rate of 1.5%. Create an equation that models the population of deer after X. This is going to be exponential growth. Okay. According to your equation, what will be the deer population in 2028, which is in 10 years? Here's what you got to watch on this one. So you get Y equals A.
No idea how to do that negative million number.
Now R, this is 1.5%. Make that 0.015. Make sure you gotta convert that to a decimal. You gotta move it 2 to the left. So now when we're typing in, or when we're setting up our equation, A is your initial amount, which is 275,000. 1 plus 0.015 to the t power. Now that's the general equation. You can just make it 1.015. What's it gonna be in 2028? Well, what do we let t equal? 10. Let's equal 10. Substitute that in. All right, go ahead and use your calculator. And then type that in. To the 10th power.
That is a big number.
How do we get that?
Actually, it's 390,000.
I'm behind.
The amount of years.
Oh my God.
The last one was bigger than this.
So
If it's not
No,
really.
it wasn't.
Small, no, it wasn't.
So hard.
A negative number.
Oh,
Much smaller.
maybe it's a zero on the first one.
It should be.
Would be another zero. Morgan, what'd you end up with?
319,148.
49.
What?
149?
Yeah,
123.
What? Does it round up?
This is so bad.
Yeah, it's 0.7269.
323. 935.
Yes, you can.
No, you can't have half that.
Oh, it's a 10.
10.
Yeah, never mind.
All right, those last three down there. Hey, settle down. What's that? All right, now this is just from this last chapter, just kind of hit it real quick again, just kind of help it sink in. Remember, you cannot add if they don't have the same inside. So you always have to simplify first. So square root of 20 plus square root of 45. 20 is 4 times 5. Jalen, put that away. Your phone, put it away. And 4 is 2 times 2. And so that gives me a pair of 2s. And so that becomes 2 square root of 5. 45 is 9 times 5, which is 3 times 3. So now you get,
three.
I have a pair of 3s.
Well, I did it the other way, like I did, oh shoot, I did 8 and 5.
Okay, that's
40.
fine.
Different numbers.
Oh shoot, I'm the next.
Different number. All right. 5 square root of 5, because you have to add the 2 and the 3 together. Okay, for that one. So you end up with a case where they can be added. Remember, you do not add the insides. Leave that as it is.
No, not really.
All right, 16. Zane?
I have the answer.
All right, what do you got?
4 c squared d to the 5th square root of c.
Okay. Zane is correct. Hey, hopefully. Hopefully that you're not doing a factor tree on 16. Hopefully you just know 16, square root of 16 is 4. You've done that enough. You should know that off the top of your head. And then remember what you do with the exponents. You basically cut them in half. So 10 divided by 2 is 5. And if it's an even number, there's nothing on the inside. But c to the 5th means there are 5 c's. 1, 2, 3, 4. You get 2 pairs. And so that's where the c squared comes from. And it leaves 1 on the inside. You always have 1 left over if you have an odd power. Okay. You can just reduce it by 1 and cut that in half to get the c squared. Now this last one here, simplify. You're not allowed to have a radical in the denominator. So for this one, you just multiply the top and the bottom by square root of 2. When you do that, 7 times 2 is square root of 14. Square root of 2 times square root of 2 is just going to be 2 because it is the square root of 4. But we know the square root of 4 is 2. Anytime you multiply a square root times itself, you just end up with that number. You do want to see if 14 simplifies. It doesn't, so we're not going to mess with it. Okay, it's just 2 times 7, so you'll leave that. That'll be fine. All right, last assignment. Last assignment. Skip 45. We didn't do that one.
Yep.
That will not be on the exam.
What is it?
But do those others. So 42 through 55. Double assignment, 20 points.
I gotta ask you. I gotta ask you something. Okay.
Fire in the hole.
Like last month, mine was a 49 to 65.
Yeah.